So with that, let's get going. You can see we did a lot of field work this summer. It was hard, but we tended to have some fun doing it. Learned a lot of things, and we learned a lot about the lake water, what to do about the supply, what to do about the habitat. And with that, I'll ask our first speaker to come up. David Mosher.
Thank you, Joe. So as Joe alluded to, we focused a lot on Lake Marion over the summer. And some of the key issues that we identified are these 5 listed here. First was the issue of seepage. That is, what water does Lake Marion need to sustain its current water levels? The lake is currently fed by diverted dam water, and if that dam water was removed, then how are you going to supply the lake, and where does that water come from, and how much water do you need? This gets into issues of water supply as well as water quality. We looked at the current water quality of Lake Marion and assessed if there are opportunities for improving Lake Marion's water quality. The last 2 are habitat improvements. Fisheries was identified as an important resource for Lake Marion. Mazomanie Kids Fishing Day being an important one, as well as the shoreline habitat. So the first issue is seepage. And seepage really is answering the question, how much water does Lake Marion require to sustain its current water levels? And this can be explained by looking at Lake Marion's water budget as a whole. Looking at the inputs that Lake Marion is receiving for its water and the outputs. These inputs can be through precipitation and runoff. And we looked at historical records for Lake Marion to see how much precipitation Lake Marion receives annually. In addition, evaporation would lose water from the lake, how much water is being evaporated from Lake Marion annually. And we estimated the size of Lake Marion and ran some models to estimate those numbers. And it turns out that evaporation and precipitation really cancel each other out. So the factor that really justifies, or not justifies, but that Lake Marion needs is seepage, which is shown by this arrow on the right here to the right of groundwater. So seepage. We tried to estimate seepage in 2 different ways. The first way was through use of seepage meters, which is the orange barrel that I'm carrying up there in the top right. These barrels are installed in the bottom of Lake Marion or into the side of Lake Marion, underwater. And if you attach a plastic bag to them with a known amount of water, and you wait a certain amount of time, you can take that bag back out and then see how much water has flown through that, or not flown, but seeped through that space. And that'll give you a rate in gallons per minute how much water is seeping through that area. The other way we estimated seepage was through lake shut-off experiments. One of the major lake shut-off experiments that we performed was this fall, from September 27th to October 15th. This is a long 2.5-week experiment where we shut off the inlet, the outlet, and all the culverts between the lakes. In addition, 4 staff gauges were installed, and we monitored these almost daily, sometimes every other day, for the lake and the pond levels. And you can see Michelle here installing one of these gauges so you can measure the change in water depth. So results. The first result that we found is that the seepage rate is not constant. Lake Marion's seepage depends on Lake Marion's water level. So depending on what water level you keep Lake Marion at will affect how much seepage Lake Marion requires. So this seepage, or this water level is controlled by a structure at the outlet. This outlet has boards that are in place that are just planks of wood. And currently there are 3 boards in place, which is when we started the experiment. This is higher than Lake Marion's usual water level. This was put there for Kids Fishing Day to raise the level of the lake. And you can see here that at 3 boards, at the beginning of the experiment, it was 462 gallons per minute. This is a really high level. However, as the lake level dropped, we got down to 214 gallons per minute at the level of about 2 boards. This seepage rate is the normal level for Lake Marion. However, if you were to go lower than that and draw down the lake, you can see that the seepage rate drops dramatically, all the way down to 99 gallons per minute if you only have 1 board installed. So obviously some of those numbers are pretty high, especially at 3 boards, so there's some efforts you can do in order to reduce the seepage for Lake Marion. One of these methods is through dredging the lake. Dredging can increase the depth of the lake, and by doing this, you can draw down the lake. So currently Lake Marion's deepest spot is around 6.5 feet. However, if you draw the lake down a foot, now your deepest spot is 5.5 feet. But if you were to dredge and then draw the lake down, you can still keep that 6.5 foot deep spot that's good for your fishery. And in addition, dredging will provide materials that you can use to reslope the banks. And resloping the banks is our second major recommendation for reducing the seepage. Reconfiguring the banks will, you can do it in a couple different ways. One is, like I said, resloping the banks, which will add a grade. Currently, the banks in Lake Marion are pretty vertical, which adds a lot of seepage, but if you reline them with extra material, including clay, you'll reduce that side seepage. And we calculated the potential seepage reduction to be about half if you reconfigured all of the Lake Marion banks. The second issue we looked at was identifying a new water supply for Lake Marion if the dam were to be removed. The first water supply that is currently Lake Marion's water is Black Earth Creek water, and the second alternative is groundwater. Now Black Earth Creek water, even if you remove the dam, you could possibly use it either through diversion or pumping, and we wanted to assess the validity of this in terms of water quality improvements for Lake Marion. So we know that Lake Marion is seeping water, and we did a study of Lake Marion to see how this was occurring, and we came up with this diagram which shows Lake Marion perched above the water table in reference to the creek. You can see the creek here in the bottom right, and Lake Marion is above that. This means that you cannot simply divert water from the creek into Lake Marion and use gravity to flow water from the creek into Lake Marion. It must be pumped up to Lake Marion, or you have to pump groundwater into Lake Marion. And you can see major seepage is occurring from Lake Marion from the sides. However, there is still a small amount of seepage occurring from the bottom. So even if you reline the sides with clay, you're still going to have to deal with that small amount of seepage. We then looked at the water quality that's currently in Lake Marion. We tested for phosphorus and for sediments and found that Lake Marion is currently very high in phosphorus and has a lot of sedimentation, which leads it to be a eutrophic lake. We then tested the Black Earth Creek water, which is also very high in phosphorus and in sedimentation, which makes sense because Lake Marion is receiving its water from Black Earth Creek. The third test we did was through looking at the groundwater, and we assessed the groundwater for phosphorus and found that it contained no sediments. However, the phosphorus in the groundwater was relatively low, especially when you get down below around 80 feet, was when it has a major difference between it and Lake Marion. So we recommend groundwater as the new water source for Lake Marion based on water quality. It's technically feasible, and it has the potential to improve the water quality of Lake Marion by reducing those phosphorus inputs. However, things that would still need to be determined are a pump location and a pump size. We did not do this, but using the data we found for gallons per minute, you'd be able to contact an engineering firm and they could help figure out an adequate pump size and location. For improving Lake Marion's water quality, there are a couple alternatives that we have. The first is managing the nutrients that are currently being put into Lake Marion. And you can do this by increasing the buffer zone that's currently around Lake Marion. What I mean by buffer zone is the amount of land that's undisturbed around Lake Marion that it would be unmowed. So currently it's mowed right up to the edge of Lake Marion, and if you're to mow farther out, you'd create a buffer zone that would buffer the wind and deter geese. By buffering wind, you're preventing wind from coming in, going across the lake, which disturbs the sediments. And these sediments are rich in phosphorus, and they add nutrients into the water column. If you have that buffer zone, it deters the wind, kind of slows it down before it goes across the lake. And deterring geese helps a lot because geese are a major nutrient input into the lake from their excrement, and they're in such high numbers that it really has an effect on Lake Marion. Reducing turbidity, in addition to reducing that wind input, you can also manage the carp. There are carp in Lake Marion, we've seen them, and carp are a major contributing factor to resuspending sediments. They like to burrow in the sediment and mud and really get that sediment up into the water column. And again, that sediment is very high in phosphorus. So if you remove them, you can remove a potential source of sedimentation. Another thing would be preventing winter fish kills. One way to do this would be through aeration. Now aeration would be recommended if you were to switch to groundwater. Groundwater is lower in dissolved oxygen than the Black Earth Creek water. This makes sense because Black Earth Creek water is open to the air, open to the atmosphere, while the groundwater is 80 feet below ground. So if you do use that source of water, it's recommended that you aerate it to prevent these winter fish kills.